Okay, so this is the next step in our lecture after our paper lecture, and this is adding vectors with components and unit vectors. All right, this is going to make some more sense here. So we're going to cover vector components, unit vectors, and adding two vectors together. How do you add two vectors together? Okay, real quick review from last time, with air quotes. Okay, we have a vector A, and we have a vector B. Okay, we're going to make a vector R that we are setting equal to A plus B. So we take our two vectors, A, and B, we line them up tip to tail, okay, and we draw what is called our resultant. Okay, so this guy right here is a resultant. That is the resultant vector. I know I'm drawing it really, really small, but that's that is the resultant vector. It's when you do some operator on your vectors, you get that. Okay, and so if we take A to equal 10 meters and 30 degrees, and we give B its value of 6 meters and 45 degrees, this is what you do not do. A disaster beyond your wildest imagination will occur if you add these the way I just added them on the screen. 10 meters plus 6 meters equals 16 meters. 30 degrees plus 45 degrees equals 75 degrees. Therefore, our new vector is 16 meters and 75 degrees. That is not the way to do it. Please don't do that. Are we clear? Okay, if you do that, you will receive no credit on that problem.
Can you tell Ashmi to stop?
All right, so you will not receive credit if you add those vectors in that way. All right, so we're going to come up with a new coordinate system. And there is vector A, which is 10 meters and 30 degrees. Okay, and we're going to, and now this has two components to it. It has vector A in the y direction, and there is a vector A in the x direction. Okay, these are the components to vector A, AX and AY. Okay, in fact, if you add those two component vectors together, you get our original vector A. You add them tip to tail, and you get that component, or you get that original vector. Now, AX, in that case, is equal to A cosine theta. So it's going to be, it's the adjacent leg to the hypotenuse, or it's the adjacent leg to the angle in the hypotenuse. And so the length of AX is given by A cosine theta. Yeah? Okay. So it's going to be 10 times cosine 30, which equals 8.67 meters. Okay, then we do the same thing with AY. We give it the same treatment. It's going to be A sine theta, right? Because it's the other one. It's the vertical one. And that's going to be 10 times sine of 30, which is just half of 10, so it's going to be 5 meters. All right, so we have these two component vectors of A. We've got A is 8.67 meters in the x direction and 5 meters in the y direction. This gives us a total magnitude of 10 meters at 30 degrees. Okay, now here's B. It's at 45 degrees. It has a component bx and by. Okay, and so in this case, by equals sine of 45 degrees. Okay, which is just going to be 6 times the square root of 2, or root 2 over 2. So that's 4.24. And then we have the 6 meters times cosine 45, which is the same stuff. So that's going to be 4.24 also. So now we have these two components of A, and we have the two components of B. All right, so we know that vector A is 8.67 meters in the x direction, and is 5.00 meters in the y direction. Okay, these are not, Corey, 8.66 plus 5.0, right? Or 8.67, that should be 8.67. Like that, I meant, why didn't that fix? I thought I had that fixed. Okay, 8.67 plus 5.0. Okay, but there's got to be an easier way to do all this. This is ugly and it's tedious, and believe me, you don't know from tedious yet in this class. Okay, so we need to remove as much tedium as possible. So we come up with unit vectors. Okay, we have a unit vector that means in the x direction, and it is given to us by the operator I hat. As in the letter I with a hat on it. I hat. Okay, all this means, okay, it is called a unit vector, okay, because it just means one. It doesn't mean 1 unit, so it doesn't have any dimensions to it. It's not 1 meter, it's not 1 second, it's just 1. But it sends your magnitude in the x direction. Okay, it causes your, whatever value you have, to go into the x direction. Okay, so it is just 1 in the x direction. Okay, and that one is the unity one. It just means 1. Okay, we have j hat. J hat is the y direction. It is defined as 1 unit in the y direction. And yes, we do have one more, and I'll let you guess what it is. It would be k hat. K hat is 1 unit in the z direction. We don't deal with z a whole lot, but we do from time to time. So you need to understand k hat. Question?
Is like the dash in front of the I hat included, or is it just
No. It was just it's just a dash.
Oh, okay.
It's leading, yeah. Okay, so the A vector then that we have is going to be A equals 8.67 meters I hat plus 5.00 meters j hat. Okay, or if you don't like saying I hat and j hat, like I hate saying I hat and j hat, I like writing it, okay, because it's a much simpler way to write in the x direction and in the y direction. So, we'll say 8.67 meters in the x direction and 5 meters in the y direction, but we'll write on the paper I hat and j hat. Okay. All right. Okay, and 0 meters k. Because if it's only in the xy plane, then it is not in the z direction at all. So we get a 0k there. Okay, B then is going to be 4.2 meters I hat and 4.2 meters j hat. Now this, you guys might be seeing where we're going with this. This is how we're going to start adding our vectors together. Because There's our A. And now there's our B. And if we're going to add them together, we go tip to tail, right? So there's our A vector and there's our B vector. So we have AX along the x-axis, and we have AY right there. Then we have BX and BY. Okay. So I'll give you a little time to draw those. But our resultant is our R hat. And that gives us a big Rx across the top and a big Ry coming up from the bottom. Okay, and those are the components of R hat. But you can probably see graphically what's going on here. Is that we're going to have a that distance right there is going to be the sum of two of our components, right? And that distance is going to be the sum of the other two of our components, right? One's going to be the sum of the I hats, and the other's going to be the sum of the J hats. Does that ring a bell? Does that sound good? All right. So R will equal Rx I hat plus Ry J hat. But Rx equals our Ax plus our, so the component of A in the x direction plus the component of B in the x direction, and our Y equals our component of A in the y direction and B in the y direction. And lucky for us, they're like terms. Okay, so they're going to add like components. So here's where we do the calculation here. So we've got A is equaling 8.67 I hat plus 5J hat. B is 4.24 I hat plus 4.24 J hat. And if we add them together, we're going to get R equaling 12.91 I hat plus 9.24 J hat, which should jive with what we drew geometrically, what we drew on the graph. That we're going to have a longer x and a longer y for R. Does that make sense? Okay. So, you may be asked for magnitude or any direction to your vector. So you may be asked for magnitude and direction to your vector. Okay, magnitude and direction from a previous lecture is going to imply what kind of coordinates?
Polar.
Yeah, these are going to imply polar coordinates. So if our R vector, we found our components, I hat and J hat are going to be 12.91 and 9.24, then how do we work these? Well, we start throwing them into, we go from rectangular to our polar. We know that the length of R is going to be the square root of these guys, right? We find the distance. And that winds up being, roughly 16. Okay, and then our theta is going to be the arctan of Ry over Rx. And we plug that into our calculator, and we'll get 35.6 to be our degree measure. So our magnitude and direction is 15.9 meters at an angle of 35.6 from the horizontal. And that's it.
Like, yeah.